Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The molecule consists of 4 cyclobutane rings fused in a linear row bicyclopolycyclic system. The Br is attached to the carbon at the junction between the second and third rings. This junction carbon connects to 2 ring systems on either side. Moving on to the next step. The carbon-bearing Br is the potential stereocenter. It is bonded to Br, H, implicit, and the 2 ring junction carbons leading into the left bicyclobutane portion and the right bicyclobutane portion. Moving on to the next step. The left half of the molecule, 2 fused cyclobutane rings, is identical to the right half, 2 fused cyclobutane rings. Therefore, the carbon-bearing Br has 2 identical substituents, the 2 equivalent bicyclobutyl ring systems on either side. And for the final step, because the 2 substituents on either side of the Br-bearing carbon are identical mirror image equivalent ring fragments that are in fact the same, this carbon is not a true stereocenter, it has 2 identical groups. A carbon with 2 identical substituents cannot be a stereocenter. Since there is no stereocenter, the apparent chiral center has 2 identical ring substituents due to the molecular symmetry. There are no stereoisomers at all, and therefore 0 optically active isomers. Options B, C, and D assume the existence of 1 or more stereocenters generating optically active forms, but the molecular symmetry eliminates chirality entirely. Therefore, the correct answer is A. Therefore, the correct answer is option A.